Today we're diving into something truly massive, something that makes Mount Everest look like a small hill and regular volcanoes look like tiny pimples on the Earth's surface. We're talking about supervolcanoes. Now I know what you're thinking. Is this another disaster movie plot? Well, not exactly, but the reality is even more mind-blowing. So what exactly is a supervolcano? Forget the classic cone-shaped mountain you picture in your head. A supervolcano isn't a mountain at all. It's more like a giant hidden underground plumbing system for magma. Imagine a massive chamber miles and miles wide, buried deep beneath the ground, just simmering with molten rock, pressure building up over hundreds of thousands, sometimes millions of years. These aren't your everyday geological features. The official term is a caldera-forming volcano, which means that when it erupts, it's so powerful that the ground above the magma chamber collapses, creating a massive crater called a caldera. Think of it like a giant underground balloon. As it fills with more and more magma, the pressure becomes immense. Eventually, the crust above it can't hold it in anymore. It fractures, and then, boom. The eruption isn't just a stream of lava. It's an explosion of unimaginable force, blasting ash, rock, and gas high into the atmosphere, like way up into the stratosphere. We're talking about an eruption, at least 1,000 times larger than the Mount St. Helens eruption in 1980. That's a scale that's really hard to wrap our heads around. So, where are these behemoths hiding? One of the most famous is right under Yellowstone National Park in the United States. That beautiful park, with all its geysers and hot springs like Old Faithful, is actually the lid of a giant, active supervolcano. The entire park, basically, sits inside a massive caldera that's about 45 miles long and 30 miles wide. The heat from the magma chamber below is what powers all that amazing geothermal activity. But Yellowstone isn't alone. There are others around the globe. Lake Toba in Indonesia is another one. It's the site of the largest known eruption in the last 25 million years, which happened about 74,000 years ago. The lake you see today is actually the water-filled caldera left behind. Others include the Taupō volcanic zone in New Zealand and the Flegreian fields in Italy near Naples. These aren't just ancient history. They are active systems that scientists monitor constantly. Let's get into the nitty-gritty of what happens when one of these decides to go off. The immediate effects are, to put it mildly, catastrophic. Anything within a 100-mile radius would be instantly annihilated by something called a pyroclastic flow. This is a superheated, fast-moving cloud of gas, ash, and rock fragments that incinerates everything in its path. It moves at hundreds of miles per hour. There's no outrunning it. Then there's the ash. And we're not talking about a light dusting. A super-eruption would blanket entire continents in a thick layer of volcanic ash. For example, a Yellowstone eruption could cover the entire United States in several inches of it. This ash isn't like campfire ash. It's made of tiny, sharp fragments of rock and glass. It's heavy, and when it gets wet, it turns into a concrete-like sludge. It would collapse buildings, contaminate water supplies, and grind all transportation and infrastructure to a halt. It's also incredibly dangerous to breathe in, for both humans and animals. But the biggest, most far-reaching impact would be on the global climate. All that ash and gas, particularly sulfur dioxide, shot into the stratosphere would create a veil around the planet, blocking out sunlight. This would trigger a volcanic winter. Global temperatures would drop significantly, maybe by 5 to 10 degrees Celsius. That might not sound like a lot, but it would be devastating. This sudden climate shift would lead to widespread crop failures and a collapse of the global food chain. Growing seasons would shorten or disappear altogether in many parts of the world. Think about it. Less sunlight means plants can't photosynthesize. No plants means no food for us or for the animals we rely on. This would lead to a global famine, a crisis on a scale humanity has never faced. The Toba eruption I mentioned earlier is a great case study. Scientists believe it plunged the Earth into a volcanic winter that lasted for years. Some researchers even theorize that it created a population bottleneck, drastically reducing the early human population and impacting our own genetic diversity. It shows just how profoundly these events can shape the history of life on Earth. Now, before you start building an underground bunker, let's talk about the likelihood of this happening. The good news is that super-eruptions are incredibly rare. We're talking on a geological timescale, with major events happening maybe once every 100,000 to 200,000 years. Scientists at places like the Yellowstone Volcano Observatory are monitoring the system 24/7. They track ground uplift, earthquake swarms, gas emissions, all the vital signs of the volcano. Right now, there are absolutely no signs that Yellowstone or any other supervolcano is about to erupt. Most of the activity we see, like the geysers and small earthquakes, is just the system letting off a little steam, which is normal and healthy. It's like a pressure cooker with a working safety valve. The most likely volcanic event at Yellowstone isn't a super-eruption, but a much smaller lava flow or a hydrothermal explosion. These have happened in the more recent past, and while locally significant, they wouldn't have any global impact. So supervolcanoes are a powerful, awe-inspiring force of nature. They are a fundamental part of how our planet works, shaping continents and influencing the course of life itself. While the thought of an eruption is terrifying, it's also a reminder of the immense power simmering just beneath our feet. Understanding them isn't about fear-mongering. It's about appreciating the dynamic and sometimes violent planet we live on. It highlights the importance of science, monitoring, and being prepared. The study of supervolcanoes helps us understand Earth's history and predict potential future hazards, allowing us to build a more resilient society. It's a fascinating field where geology, chemistry, and physics all come together to unravel the secrets of our planet's inner workings. They are a testament to the fact that the ground we stand on is anything but static. So next time you see a picture of a geyser at Yellowstone, remember the colossal power it represents. It's not just hot water. It's a window into the fiery heart of a sleeping giant. Thanks so much for hanging out and learning about this with me today. It's a huge topic, and we've only scratched the surface. If you found this interesting, make sure to hit that like button and subscribe for more deep dives into the wonders of our world. Drop a comment below with what you want to learn about next. Stay curious, and I'll see you in the next video.